Hello everyone. My name is Dhara Parmar and my project is titled Loan Detection Using Machine Learning. The main goal of this project is to build a machine learning that predicts whether a loan application should be approved or not based on a various applicant details. First cell, importing zip and pandas. This is imported needed library. Zip is a used for open files. Panda is for a data manipulation. In this first step, I am uploading my file in a read form. In second cell, print df.shape. Show the number of row and column in your dataset. Uh, it is my dataset's row and column numbers. In next, in next third cell, I am uploading all the libraries. In next one is uh, this one, print.df, df.column name column. It is used to showing various features available in datasets and also all column names. Uh, df.info. It is providing details on each column types and missing values. So here it is all my column names and all the data types and information we have. Okay. So next cell is a is null dot sum. It is count the number of missing values each column. It is key to use understanding data quality and decline on a importance. Next one is describe. So describe is a use to basically use mean, maximum, and minimum value in every data. So this is my data and like it is a mean, maximum, and main. So you can see this all the columns have minimum and maximum value, average value. So this is all the values are. So in next cell we are going this one. In next cell I am importing SQL and logistic regression, classification, confusion metric, and also accuracy score. SQL is used to import a tool for splitting my data for a training testing. So next I am splitting my data into X and Y. So first is X is equals to df drop loan status label X is equals to 1. It is a separate feature all column expect label for model training 1. And the next one is a Y, Y df loan status label. This is a target variable what the model should be predict. If load is a root to equals to 1 or not is equals to 0. So next I am splitting my data into x x trace, x trace, y trace, y trace equals to trade is split xy trace size is equals to 0.2 random set is equals to 42. It is a split the data into a training using my model to learn and testing used to measure accuracy. Formal splitting is 80% training, 20% testing data. So I'm going to next one. Next one, I am just applying if conditions to check my data is perfect or not. So first I'm using first 5 rows to match this condition, and next is the giving the shape of this data, and here my data look like this. Uh, okay. So next is y is equals to cf. and x equals to df dot drop, column equals to target full. Sir, I am check the numerical feature count and non-numerical features. Uh, Next step, building simple processor. So I am importing sklearn processing uh, pipelines for everything. So this I'm starting. Okay. So in a numerical transformer pipeline, so importer simple importer. Okay. So median. It is a define a pipeline for a pre-processing numerical feature, typically involving median importance and scaling. So I am using if conditions, if and else conditions in this one. This is a preprocessor column transformer. It is used to apply preprocessing pipelines to the appropriate columns before finding data to a model. So I am also train my test data and train data. So it is my test data size and it is my sorry, it is my train data size and it is my test data size. In next cell, I'm going to model. I am constructing three separate model pipelines. It is a logistic regression, random forest, and gradient boosting. So each pipeline starts with the same processing but applies a different classification. For examples, I am using for loop name pipe in model item. Instead, put through each model training into on data and evaluate its predictions. Key results are printed for each model. So it is a printing all all models for all models. So this is for my logistic regression. It is my random forest and it is for a gradient boosting. We can see the difference between that three. First one logistic is a 76%, random forest gives a 75%, and gradient boosting gives me 78%. I am just summarizing the all data into one form. So I basically check the F1 score, accuracy, uh, so my F1 score, you can see the 63 for gradient boosting, uh, logistic for a 61 and 64 for a random forest. And accuracy give me around 90%. So it is uh, quite good for model learning. So this is the normal and check the all the like using random forest and check the graph physically to visualize my data. Easy visualization for. So it is my precision recalls F1 score support for logistic random and gradient. It is give me it accurate 90% for my data. All give me the 90%. You can see this 90%, 90 average 90%, and my score is 75, 78. Quite good. Uh, in behalf of these my data, I am use a graph to visualize what type of model is best for my machine learning project. So I am just giving the three models graph and next it is just bef- before graph also. This is a vision and recall graph. Mm, it, same this one. Okay. So it is my all project. You can see. Uh, Thank you.